Hello everyone, my name is Brian Broll and today I'm going to be talking about making CS more engaging for all with NetsBlox. So this was initially prepared to be delivered in a workshop format, so a few of these things are going to be adjusted for use as a webinar, but regardless we're still going to follow basically the same overall structure or outline. We're going to start with an introduction to NetsBlox. Including some important abstractions we'll be touching upon again later and using a lot later, namely remote procedure calls and messages. Then we're going to jump into a couple hands-on projects. Since this is going to be a webinar format, I'll go a little bit faster than we would if it were a workshop, because of course we can pause and go forward and backward if anything's missed. But for these two projects, we're going to first do an interactive COVID-19 map and then jump into a chat application as well. And finally, we'll touch on a few different demos that showcase a number of the other capabilities that we don't really have time for in this webinar, and then we're going to wrap it up with some concluding thoughts and other efforts that are related and worth mentioning. So before we get started, one key concept that's going to be coming up multiple times today is this idea of distributed computing. Now, a distributed program or application is a program that runs on two or more computers that are working together to achieve some goal. And there are examples all around us, including a number of the images shown in the lower right here. So, for example, this includes browsing the webs, most mobile applications like texting or using navigation, multiplayer games, volunteer computing, as well as things like social media. You see these in cars and planes and a bunch of other complex vehicles or robots even, and of course many more. As I mentioned, we have a few of them, a few familiar logos here shown in the lower right. So, with given that distributed computing is all around us, it's particularly valuable to be teaching to make these concepts accessible to young students. Not only because it's just a relevant it's increasingly relevant in today's world, but also because it can make programming more exciting, interesting, engaging, and captivating. One such effort to do this, to make distributed computing more accessible to novices, that is this programming environment called NetsBlox. So it's a blocks-based programming environment that, as I mentioned, is designed to make distributed computing more accessible to young learners. It's an extension of Snap, if you're familiar with that blocks-based environment from Berkeley. Otherwise, it's similar to Scratch if you're unfamiliar with Snap. So when we keep referring to blocks-based programming environments, some of the language elements here are shown in the lower right. So these are some of the blocks that can run and do things that we can then use in our programs. Now, NetsBlox really brings two main abstractions that open up the doors to networking. These are remote procedure calls, or the ability to invoke some functionality that's running remotely, and message passing, or the ability to send and receive data over the network to one another. Now these abstractions, although designed to make distributed computing more accessible, actually open up the doors to make a lot of other advanced concepts much more accessible, including cybersecurity, robotics, and Internet of Things, as well as a number of others, because these concepts are often either dependent or can at least be enhanced by using networking capabilities. So let's jump into the first of these abstractions. Remote procedure calls, as shown in the lower right here, enable users to invoke remote functions, in other words, such as those running on the NetsBlox server, as if they were local custom blocks. So they can use them just like any other block or piece of code that's running in this environment. And this really opens up an opportunity for the students to be able to do things like access external APIs like Google Maps, as we can see here in the top block in the lower right, make real-world data accessible, like the NetsBlox, which makes a lot of COVID-19 data available to the students, which is hosted and curated by Johns Hopkins University, among a bunch of other things, such as the cloud variables one below it, where they can set and get variables that can be shared across projects, such as like a high score list for a game or a lot of other options. Now these RPCs are grouped by functionality into what we call services. Now some of these services that are currently supported include like Google Maps integration, COVID-19, which I mentioned gives access to the COVID-19 dataset curated by Johns Hopkins, the Human Mortality Database, MovieDB, historical data or temperature from Berkeley Earth, some ice core data from NOAA, where they can look at the temperature trends over the past 800,000 years, and many more. Now, the second main abstraction that is added by NetsBlox, again to make distributed computing more accessible, is this idea of message passing. Now this isn't really a new concept that was by any means created by NetsBlox, but certainly it is new to bring this sort of concept and and use these abstractions within a block-based environment. So messages are similar to the events that already exist in Snap, but they can actually be sent across programs via the internet. So this makes it possible to start doing things like have programs communicate to make things like a multiplayer game possible, or chat applications, one of which we'll see later. And we can see an example of what sending and receiving a custom chat message type might look like in NetsBlox with these two blocks below. So you can see in this case they're sending these chat messages, and a chat message has two fields, sender and text. So when you send it, you can of course fill in these two fields and send it to whomever you'd like. And when you receive it, you have those two data fields available as variables. All right, without further ado, let's jump into some hands-on activities. So the first thing that we're going to build is an interactive COVID-19 map. So before we get into the map itself, I have a little bit of code here already, so let's create a new project. So before we get into the COVID-19 portion, it would be useful to just kind of break it into a smaller step and start with just creating an interactive map. So for those of you who aren't familiar with NetsBlox, and before we jump into some of this, the actual programming parts, or familiar with NetsBlox or Snap, of course, let's quickly cover or briefly cover a little bit of an overview of the environment so we can get kind of a handle on things before we progress. So first of all, in the top right here, this big white area is what we call the stage. It has a sprite on it which can have its own behavior and appearance. So in other words, it can have its own code and like images to represent itself. We have some buttons in the top right, like the green flag, which is usually used to start a program. The red stop sign kind of outline here is what can be used to stop it. And underneath the stage, we have the sprite corral where you can see all of the sprites that exist as well as make new ones. We also can select the stage, which can have its own code defined for it as well. When I select these different sprites or the stage, this will actually update the center area here, the scripting area, where we actually write our code. So if I add some block to I'm selecting the gray sprite and then select the stage, of course the block is gone now because this behavior or this code is owned by this gray sprite. And then the last real important portion that we'll cover here before we just start jumping into some hands-on stuff is this left side here. This is the palette. So this is where we have all of the different blocks that we can use to construct our programs. So without further ado, let's jump in. So I'm going to create a new project again just so we don't have all those extra sprites, and I'm going to start actually by making an interactive map, and this is going to be for this stage. So I first click on the stage, and now I'm going under the network tab, And before we actually get into this idea of an interactive map, we first want to start with just creating some map. In other words, let's just simplify, let's just forget about the interactivity for now, and let's just try to show a map on the screen. So if I go under the network tab, we can see we have this call block, or this block that says call, which is used to call RPCs, and we can select the first dropdown, which will give us the service, which is kind of like the category or group of RPCs. So we can see Google Maps is one option, and the second dropdown actually shows us a list of the available RPCs for Google Maps, or for the Google Maps service. So if I select something like Get a Map, we can see that the block automatically updates, and now we can see all of the inputs that are required for this RPC. So we have latitude, longitude, width, height, and zoom. So if I select zoom and enter something like, I don't know, 5, and for latitude and longitude, I can just enter some value, I guess, like 35, longitude, I don't know, -86 or something. And then for the width and the height, it'd be nice if it was the same width and height as the stage itself. So if I actually go into the sensing category and go to the bottom, I can actually see we have a stage height block and a stage width block. And now when I click on the block to run it, we can see a little speech bubble pulls up, and we have this very small map. Now it's hard to know if this map is exactly what we wanted when it's so little, so let's select this looks category and use switch to costume to make our stage actually look like this. Alright, there we go. Now with that we have now a stage that looks like a map. In other words, our background went from being just white to being a map at this latitude and longitude with this zoom level. As I mentioned before, these programs generally start when the green flag is clicked. So let's drag that block over. And as one little tip, you can also kind of simulate the green flag being clicked by just hitting Control-Enter. So with this we have a map. And now let's worry about the part that we kind of put on the back burner. In other words, let's make this map interactive. So one way to make it interactive would be to, well, first say add zooming. So if we want to add zooming, we probably want it to zoom in when we press like the plus key. So we can grab this when space key pressed block and switch space to the plus sign. And now we could, if we were just doing something super simple, we could just type this 6 in here. Now, I'm showing this more as a demonstration because this certainly isn't the way that you would like to do it. But if I hit the plus key now, we can see it does zoom in. So that's great. But of course, the problem here is that we've hard-coded the zoom value, which really isn't ideal. What we really would like is this to, instead of it being a fixed number or fixed value, we would like it to kind of vary, or well, be a variable, a variable input. So let's define a new variable. Let's call it zoom, and we can first start off with zoom being set to, say, 5. And now instead of passing 5 to this RPC value, when we can just pass the zoom variable, which now is set to 5. So this is great, but it doesn't really help us when the plus arrow key is pressed. So when the so what we would probably like is when the plus arrow key is pressed, we might want to say change zoom by 1, and then switch to our costume where we're of course using the zoom value as well. So now we can see when I hit plus, we start zooming in further and further and further and further, which is exactly what we would like. If you're not seeing this, one common mistake is forgetting to add this switch to costume block and just change zoom by 1, because of course then we're just changing the variable but not actually updating what the stage looks like. So this is great. This is certainly giving us some level of interactivity. there are a couple little improvements that we can make. One such improvement is to make sure we don't zoom in too far. And if we keep zooming in, we would find out that I believe the limit is 25, maybe? There we go, 25. So we can't hit 26 or else it just goes back to the white background because that's invalid. And if we click on the error button here, we can see zoom is not valid. Number must be between 1 and 25. At this point, we can add an if statement, so we're actually only updating the zoom value if it is less than 25. So if zoom is less than 25, oops, there we go. Then we change it by 1 and we zoom it in. And now we can see that we will be able to zoom in until 25, and now it doesn't increase any further, so we don't get any just plain white screen, though it certainly does look pretty white. So with that, alright, so now at this point, we can clean up the code a little bit further. Actually, before we do that, let's just jump into making it interactive another way. So we worked on zooming in, and one natural extension might be zooming out, which I might leave for you guys after. And then, because it's very similar to zooming in, except of course you're changing you're changing this plus sign to a minus sign in a new script, and then of course we're decreasing the zoom instead of increasing it, and our kind of guard or check here is going to be a little bit different. In other words, we probably don't want the zoom to be too little rather than checking to make sure it's not too large. So the next thing that we could do is we can add something like say panning. So when the up arrow key is pressed, or let's say right arrow key is pressed, we might want to move the stage or move the map to the right, so we could just can kind of navigate around the world. So I'm going to reset this. So now, like before, we're going to want to look at a value that's currently fixed and replace it with something that can be dynamic or variable, or in other words, a variable. So let's look at changing the longitude. So now we make a new variable called longitude. We initially set it to -86, and then we can use longitude instead. And now when the green flag is clicked, it should do exactly the same thing. And the important part is down here when the right arrow key is pressed. So now we'll take the longitude, we're going to set it to some new value. So this new value, let's see, we want to, so this is where it's a little bit tricky, because when you're zoomed out, the longitude, the amount you move in terms of degrees longitude should be actually quite large. But as you zoom in further and further, you certainly don't want to move by the same amount we would. In other words, right now, if we think about look at this map, which is centered on Nashville, if we wanted to pan to the right, we would probably want something like North Carolina or the far right to be in the center. But if we were zoomed all the way in and at like the street level, hitting the right arrow key certainly shouldn't jump you to North Carolina. So there's actually a pretty easy trick to write the code so your longitude adapts based on your zoom level. And if we look at and basically the idea is that if we look at these RPCs, we have an RPC that's here to help us called get longitude from X. So in other words, rather than thinking in terms of degrees longitude, we could just think in terms of the map coordinates. So or the stage coordinates. If we think of the stage coordinates, well, we want to take the X value, the far right X value of the stage, and get the longitude for that value and put it in the middle. So this RPC, get longitude from an x value, will take a stage, an x value from the stage coordinates and convert it to a longitude. So this is great since we know the size of the stage. And this coordinate system is actually, here, if we look at sensing click, and we show our mouse x value, we can see that in the center it's actually 0, and then it increases much like it does in actually math. So you x gets larger going to the right and larger going up, which is a little bit different from what the coordinate system often used with displays, but a little bit more natural again for since so oftentimes people are familiar with the coordinate system used in math instead. So now the question is just what is the x value? So the x value is on the far right. Since the stage starts with a stage's coordinate system has 0, 0 in the center, if we knew the width, we could divide it by 2, and this would give us the x value of the far right. But there is actually a block for the stage width. So if we just drop that in here, now we can see that we can actually get the longitude from the x value, and it gives us a longitude. And we can just set our longitude to that value and update our map again. So now when I hit right, we can see I pan over exactly as much as we'd expect. And if we reset to the center and I zoom in and pan over, I don't move. I move, relative to the zoom level, which is exactly what we were hoping for. All right, so there's one. I've been quickly, copying and pasting this switch to costume block, and code duplication is really not great, as I'm sure you all know, because it can be a bit error prone and buggy if you forget to update things. So, for example, suppose I want to zoom in right here. I see Chattanooga on the left. I should be zooming in kind of on Cleveland. But now when I zoom in, it's nowhere to be found. And if we look at our code, this makes sense because when the plus key is pressed, we change our zoom by 1 and we switch to this hard-coded latitude. And that's not really what we were hoping for. So what we might want to do instead is actually change this common logic to being executed in an event handler instead. So we can use this when I receive block, and we can create a new event here, say update map. And now we just drag our code over for what it means to update the map. And then whenever we were updating the map with this switch to costume block, we replace it with this broadcast instead. Now we see that we don't have the same code duplication, so we just, going forward, as we add more interactivity, to say go left and down and up, we don't have to worry about actually updating the same code in a bunch of different places and things like that. So now we can see that actually if I move to the right and we zoom in here over Dillard, we are in fact still centered over Dillard. Now, as you would expect, a natural next step is to start looking at how about panning to the left or panning up and down. And I'm not going to go into a lot of detail with that for this webinar, just to kind of keep things short and moving on, and it's so similar to what we've done so far. But if you look at what we've done so far, there are just minor changes that would be needed to, say, support panning to the left, making a new script, and changing right arrow key to left arrow key, and then changing the longitude to get the left side, so the negative value, and then updating the map. And actually that's simple enough to go left. And then to be able to support panning north and south, we would need to, of course, make the latitude dynamic and update it similarly. But the same type of approach generally works. Great. So at this point, we have created an interactive map, which means we can start focusing on the last part, which is adding or integrating COVID data. So the idea might be, if we are looking at, say like the US, we might want to click on, or some part of the world anyway, we might want to say click in a region and actually see like the confirmed COVID counts for that country, or for that state. So if we want to support this, we would probably want to first, there are a few different steps. We need to know like when the map is clicked, and we would need to know where it was clicked, as well as being able to convert this X and Y coordinates to the state that it's in, and then retrieve the COVID data for that state. So there are a few different steps here. So to start, to break this problem again into smaller, more manageable steps, let's first click on the state and move the sprite to the cursor. So just figure out where the stage was clicked, again just in stage coordinates for now. Well, if we look on the left and we want to figure out where the stage was clicked, there is a block when I am clicked that we could drag out to the stage. And when something's clicked, just like we did with the update map, we could actually broadcast some notification that something or event occurred, and then instead of responding to it or reacting to it within the same like entity, or like the stage in this case, we could actually have the sprite react to it. So we could say when I am clicked, we can broadcast a new thing, map clicked, and now the sprite, clicking on the sprite of course changes the scripts here. We could say map clicked, and let's just say hello, just to see if it works. So now when I click on the map, we can see it says hello, so it knows that it was clicked. But we didn't want to just know when it was clicked, we wanted to know where the map was clicked. So if we look under motion, let's see, it looks like we could have it just say move to the location that was clicked. So we look under motion, there's a moving block or a go to. And if we look under sensing, we see a mouse X and a mouse Y. So now when the map is clicked, we could just have the sprite go to that location, and now we're getting pretty close. Now we know that the sprite's current X and Y are of course the mouse click location. Or of course we can just use the mouse X and Y location, but we can at least see that we know where the map was clicked, because as soon as the map is clicked, we can just use the mouse X and Y coordinates or values, and then we know that that's the location. In this case, of course, we're going to that location, but in the future we'll be doing something more intelligent with it. So let's look back at this call RPC block. So this call RPC block we know connects us to real world data and things like that, and we saw already in the earlier slides that it has a COVID-19 service. So if we look under science, we can see COVID-19, and it has an RPC for getting the confirmed counts. But getting the confirmed counts requires us to know the country, state, and city. Well, the first one's required, the other two are optional. For now, we'll just probably look at the states in the US, but this certainly can be easily adapted to do to work internationally and stuff too, because the COVID data is available internationally. So the question is, how can we go from the stage coordinates, which we were able to show that we can move to, and actually get the corresponding country and or city? So if we look at the call block, see if there are any other services that might help us here. Well, we know that there was the Google Maps service that we used to convert the X and Y, or the X values to a longitude, and it can convert Y values to a latitude. So this would get us closer. Now we know that we know the latitude and longitude that we want to look up the country and state for. Are there any other services that might help us? Well, here, the geolocation actually should be useful for this. So if we look at geolocation, we can see that it has options for, say, like getting the county or the country given a latitude and a longitude. So if we So this is looking like it's starting to come together. So we can create a new variable called maybe mouse latitude and mouse longitude. And now, instead of just going to this location, we could actually take the mouse y value and get the latitude that corresponds to that y value and save it as the mouse latitude. We could get the x value or get the corresponding longitude for the given x value and record that as the mouse longitude. So now when the map is clicked, we can see that we know the latitude and longitude. Alright, so this is good. This is a good start anyway. So now the question is, once we have a latitude and longitude, how do we actually get the country? Well, as we saw earlier, this geolocation service seems promising. We can use this mouse latitude and pass that in as the latitude argument, and mouse longitude for the longitude argument. Now when we call this service, or this RPC, we get the text United States. Great. So let's make a variable called country. And now we can actually record the country. A new variable called state, because for now we'll just focus on the states in the U.S. But of course, data is available internationally, so we could we're not constrained to this area. So it seems like the geolocation service might also be promising for resolving the state. So if we look at the other RPCs, we can see that there is a state RPC with an asterisk, of course, because some countries don't have states, they have provinces or other things like that. But of course in the US this is called a state, so it's more state or state equivalent. Now if we call this RPC, we can see that it says that I clicked on Alabama. So I could click in Tennessee, see that it knows that that in fact was Tennessee. Awesome. So now when I click somewhere, we can see that country is United States, state is Tennessee, and now we can see if we can actually use these to get the confirmed counts in, say, Tennessee. So let's grab this country variable, state variable. Now when we call this service, it takes a minute, and then we have all of the available data for confirmed counts in Tennessee. Awesome. So we've been able to start with a static map, add some interactivity to it, first zooming in, then panning left and right, of course leaving zooming out and panning north and south as an exercise for later. And then we were able to, when the map's been clicked on, we determined the latitude and longitude from the x and y coordinates of the mouse click, and then resolve those latitude and longitude values to country and state names. And given those country and state names, we were actually able to look up these the confirmed counts. And now this leaves us with only one more task, and that's to actually maybe show it in a more meaningful way. So if we look under the network category again, we can take another peek at this call RPC block and see if there are any useful services that we might want. Well, if we want to present this in a meaningful way, the chart service seems like it might be a useful resource. Now the chart service has two RPCs available, draw and default options. And draw takes a list of lines and then of course some options. So if we look at what the default options are, we can see that this is kind of a table of information where it has a bunch of different settings and then values for those given settings. So for example, like we have time input format, which is going to be relevant. Is it time series data? Also relevant. And things like the title, the width and the height, things like that. So in Snap and NetsBlox, these tables are really just a list of lists. So if we wanted to represent the same thing, we could just take a list, and in the inside list, say the name of the setting, like is time series, and then as the second value, we could put something like true. And now I can see we have a table with one row, is time series and true. And when we look at the default options, we know we're working with time series data, but we're not sure what the time input format is. Well, let's see. This one's a little trickier. It uses kind of the conventions used by GNU Plot and a number of other like timestamp parsing tools, but it can be a little bit tricky. Basically, they say things like %m and for like month, %d for day, %y as a lowercase y for a 2-year date or year, or 2-digit year, and %Y for a 4-digit year. And then any text in between can simply be things that are, of course, in between the actual numbers, in our case slashes. So we can say time input format. The time input format is going to be it's a month /%d /%y. Now this is one of the trickier parts, and sometimes we just make this available as like a library or custom block or something in the starter template, so we don't have to talk about the details of like parsing time input or time stamps. But if we make this data, if we use these options and pass these when it draws the chart service, it'll know basically how to parse this time series data. And now we can click on it and see that it pops up with a little speech bubble again, which is, like last time, a bit too small. So we can just click on, we can tell it to switch to the costume. And now when we click on it, we can actually see that the sprite turns into a map of the confirmed cases in Tennessee. Now, there are a lot of other little improvements that we could make here, like setting the title. So we could say that the title is going to be, well, we're going to probably want to join some text together here, since the state changes potentially each time. Confirmed COVID cases in. Then we can just say the state. And now, if you notice, when I try to click on the map, I can't see it, so I'm not actually able to click on it. I'm just clicking on the sprite. So we might want to add a little helper here, like when I'm clicked, say like hide, so now it goes away. But of course, if we're hiding when we're clicked, we probably want to make sure that we're showing, after we plot the map. So we could say something like click on Kentucky. And now we can see it knows that the state's Kentucky. Now it says confirmed COVID cases in Kentucky, and we can see the COVID cases over time. Now there's a lot of room for improvement in this exercise as well. Of course, in the sake of time, I'm going to probably cut it short and just leave more of these as exercises for the participants or anyone following along. We do have walkthroughs available for these, so you can see how to go from an empty project all the way to the end, not skipping, of course, or where you're actually completing things like the panning north and south, and some of these other features that I've just been kind of mentioning in passing for the sake of time. So some of these would be like X and Y labels, output time parsing, so you could say like, do you want this to be, month and day, or things like that. We could use a similar format as we did here, and a number of other features like that. All right. So we can do things like zoom out. Oh wait, whoops, I forgot. I left zoom out as an exercise for the user. So maybe I will just restart this guy, and we could click on something like Minnesota. Now I can see that the state is Minnesota, and here are the confirmed COVID cases in Minnesota. These are cumulative, of course, but we can see them since the beginning they started reporting, which I think was like towards the end of January in 2020. Was that it? I had to double check. Either way, early 2020. So, um, this concludes this kind of quick crash course in building an interactive COVID map using NetsBlox. Again, NetsBlox. I don't know if I mentioned this yet. Actually, it's a research project. It started as a research project from Vanderbilt, so the whole thing is open source and mostly sponsored by the NSF. But a few other, of course, research funding institutions have funded it over the years. But the big important takeaway there is that it's free to use in classes and things like that as well. So it's not necessarily like a so it should make it a lot easier to integrate into the classroom. All right, so this leads us to one other application that will be just kind of building from scratch again. And then before we get into a couple quick demos and then some kind of concluding slides. So let's create a new project. Now our new project is going to be a chat application. So before we start, the idea here that we would like to do anyway is see if we can get two different clients to start, maybe be able to message back and forth to one another. And it would probably be nice if we want them to be multiple for it to be set to use something like a server in the middle. So this brings us to one concept that I haven't touched on yet in NetsBlox, which is this idea of a room. Now, a room is a lot like your local area network. In other words, if this were a tic-tac-toe game, you might have, you might see two bubbles here, one for the X player and one for the O player, which both of these bubbles, or we call them roles, in the application are running on different computers. Because if we think back to that definition of distributed computing, there are multiple programs working together to achieve a single task. So each of these roles, of course, is like one of those individual programs that are running on different computers. So I'm first going to actually click on this untitled thing and just say this is like chat app. And let's see. Trying to decide if we should use a server or not. Well, let's start with just making a sender and see if we can send from one person to another. So we have a sender and a receiver, and all right. So we have a sender, but we don't yet have a receiver. So let's make another role called receiver. So there are two roles now in this room or in this project. The sender, and of course, as I've said a few times now, the receiver. I opened up a new tab that's just kind of at its own new project, and I can do things like, say, invite myself to the receiver role. So then I can actually move to the receiver role within this chat app, and we can see that on the right side, you can see under sender there's still Brian, and under receiver there's myself as well. And at the top of both NetsBlox windows, we have sender at chat app and receiver at chat app. Alright, so here we go. Now, these, although right now I'm running it on a single computer, this certainly doesn't require that, and actually it's more fun when it isn't, as either of these, I guess, could be running on someone else's computer far, far away. So the easiest might be to start with this sender. So if we want to build some simple chat application, we can first start by using this when green flag is clicked. And then since this is the sender, we probably want to say send a message. So we can send something like, hello world. And now the question is who we would like to send it to. When we select this drop down, we can see a few of the options that are available. Now these options actually are populated from knowledge of the room, so we can see that it says others in room and everyone in room, so everyone meaning including myself, but it also has receiver as one that it knows about as well. So now when the green flag is clicked, if we click that, we can see it sends a message. Oh wait, we don't see anything. So it is in fact sending a message, but the problem is that our receiver isn't doing anything with it. It's not listening for the message or anything. So when it receives the message, it just basically ignores it. So to fix this, we can add a block for when I receive a message. And for now, we can do something like maybe say that message for 2 seconds. So I can use this when I receive block and the say block, but if I want to know the contents of the message, I can actually access the MSG field, so the hello world, basically text that I entered over here, and I can just say that for 2 seconds. Now when I click the green flag, I can see that it in fact says hello world. Again, this is one aspect of it. So this is one aspect that's a lot more fun when it's not running on a single machine. But it's certainly just as exciting in the classroom, and all the students are able to communicate with one another, and of course they aren't sharing a machine. All right, so this is one start. Now we can start to make this a little bit more interesting, like have an ask in here, where it'll just ask for user input, and we could do this forever. So we always are just asking for input. And whenever we get some input, we send that text to the user. So whatever the answer was to the user. So in this case, when the green flag is clicked, it just pulls up a little dialog, and I can say, hello, how are you? And when I send it, we can see that this sprite in fact says, hello, how are you? Similarly, like we could basically combine these two types of scripts, like this when I receive message, we could say the message. I'll just say it in general, not for 2 seconds. And now probably want to do something similar over here. Let's actually just green flag is clicked. I'll just make the simpler one just for the sake of time. You could send the message to the sender. How are you? And we can see that the text shows up over here. I am great. How about yourself? Alright, and with that, even with some of our embellishments, like asking in a loop, we still have this, and making sure that they can of course both send it to each other, so they kind of have evolved from just being a sender and receiver to both being senders and receivers. We're able to actually build a very simple 2-person chat application with like maybe 10 total blocks. So this is a really fun starting point because there are a lot of natural extensions, and some of those I'll share links to with the slides. But so for example, one natural extension is to do things like try to add more people into the conversation. So when we start adding more users into the conversation, one approach would be to certainly create extra roles here. But the problem is that this is actually a fixed number then. So you can actually start looking at connecting or communicating in between projects. And again, the walkthrough that I'll share in the slides contains a link to this, where rather than just having a fixed number of people in a single project, you can kind of have this dynamic chat room where people can come and go as they please by implementing a server, which is also quite simple, and a bunch of chat clients that just send the message to the server, and then the server just forwards it to everyone who's connected. So basically kind of a middleman that knows who all is involved, so it can relay the messages accordingly, and we don't need everybody in the room to actually know everybody else and send messages directly to everybody else. Building on top of that, there are a lot of exciting directions, like encryption is a natural one that comes up. Denial of service attacks is another natural one, where someone maybe will, instead of asking and waiting, just start sending these in loops. And of course, there are the fun techniques to mitigate that, some of which we have curricula for. Actually, that one we definitely, or a decent number of which we have curricula for. And there are some exciting other ways that this, alternatively, I guess, to the server, we can go in an exciting new direction, which is looking at a mesh network. So what if there isn't a centralized kind of authority that we're communicating through, but we want to actually kind of build this ad hoc network where we get a ring of people who are sending messages to anybody else in the ring, and that has its own exciting questions about resiliency and redundancy and encryption and security and a lot of other really exciting topics. But I will save some of those for the walkthrough, just so this webinar video doesn't get too long, and hop back to the slides so we can see some other demos of capabilities that we haven't touched on just yet, and then finish up with some current and future directions, and then of course wrapping up. So we have a couple of demos of different RPCs that we haven't seen yet, one of which is like this cast of any movie application where you can use like the movie DB to search for movies of interest and show the top leading actors or actresses, and or things like access the USGS data on earthquakes, and you can visualize those over an interactive map. And this one on the right here is a bit of a more polished COVID-19 data explorer, I guess. That can be, that's an exciting project as well. So for example, let's check out some of these. So here's the movie one, the movie application. So when it starts, we default with hidden figures, but you could say something else like, I don't know, Coco. And now we can see the leading actors in Coco, or Soul. Anyway, and this is just a simple use of this RPC and kind of showcasing it in a fun way, where we can just start touching on other topics and asking other sorts of questions. We have other examples where we're doing something like building Alexa skills, or let's see, or doing things like text analysis and a number of other things like that. Where's my sentimental writer? Here we go. So for example, this is another very simple program that you can see the entirety of on the left here, or kind of in the center here. And all it does is it asks you, or basically you just type some input, and just like it's a typewriter, but it actually understands the sentiment and color codes accordingly. Like, I really like this project. So it recognizes that has a strong positive sentiment, so it color codes it in blue. If I said something like, "Are you sure it is kind of lame?" then we'd see that it's a negative sentiment, so it color codes it accordingly. We have some message passing demos as well, a number of different ones ranging from like Caesar shift encryptions and trying to do code breaking, to things like this one, which is a fun one to show, a shared whiteboard. But this one is one that's, I can show it now. It's a lot more exciting when you are actually when you have multiple users writing on it, like using it. Let's see. Name equals shared whiteboard X. All right. So with this project, I can invite myself. So there are two roles, client 1 and client 2, each of which can draw on the whiteboard, and there we go. And the results will be seen by the other person. So if I just make this full screen, make this one full screen as well, I can draw over here and see it on the other device, or draw back over here. And I can just keep alternating back and forth and drawing and writing messages to one another. Similar to the the other examples, the code for this is also not very complicated. You basically maybe these, I don't know, 50 blocks or so here. That the most complex part is just keeping a list of the coordinates as things are being dragged, and then of course broadcasting it to the other user so that they can draw it as well. This does allow you to kind of tiptoe into other interesting ideas and concepts, like consensus. Like, what if you wanted to clear the whiteboard and you wanted to both come in, or both make sure both people agreed on it, and things like that. All right. So without further ado, I'm going to quickly touch on a couple current extensions, or current exciting new frontiers that we've been exploring with NetsBlox. One of which is Phone IoT. So basically this is a mobile app that allows you to interact with, or that you can basically control and configure via NetsBlox. So your NetsBlox program can do things like place graphical elements on the screen to create like an exercise tracker shown in the middle, or it can receive a bunch of streaming sensor data, like on the right here, where we can see the how the phone, or the accelerometer data, while the phone is being rotated across these different axes. It is worth mentioning, this isn't a mobile app development environment. It's focusing on it from, again, an Internet of Things perspective, where these are two devices that are communicating and working together, but not where you're writing code in NetsBlox to deploy on the phone and then just forget about. So as a couple quick demos, I'm hoping the audio will come through here. If not, I'll just make sure that the links are available.
Here's a simple game we put together where you use the accelerometer to control the ball rolling around through a field of holes by tilting your device. The objective is to get to the upper right-hand corner where there's a green flag without falling into a hole.
So this is one small activity, or simple activity, that we've had, that students have been able to create and work on using Phone IoT. And then we also have things like this fitness tracker, which we can see here.
In this project, we combine both sensors and display to create a simple fitness tracker. We use an image display to show a map plotting the user's location, a text field to show the total distance traveled, and two buttons to start and stop the tracking. We can use the Get Location RPC to get the initial location of the device, and use some RPCs from the Google Maps service, a pre-existing service in NetsBlox, to get a map of the area. When we add a custom control to the display, it returns an ID that can be used by other RPCs to modify the content. Using this, we can set up the GUI to an initial state, request sensor updates from the location sensor, and continually update a visual display on the mobile device to match the NetsBlox stage running in the browser. When we receive a location update, we can use RPCs from the Google Maps service to convert the latitude and longitude into screen points and draw a path to the new location. We can even use the bearing field of the location sensor to point in roughly the right direction. Other RPCs from the Google Maps service are used to get the traveled distance, along with some custom averaging logic to mitigate GPS position noise. What you see is an example of me connecting to NetsBlox with mobile data turned on and walking around.
All right, so this is another activity that's really, I find, quite exciting and made possible by this Phone IoT extension and capabilities. Another front where there have been a lot of exciting developments is Roboscape. In other words, it's a robotics platform, but it has a unique twist compared to some others. So rather than connecting your robot directly to your laptop and programming it there, Roboscape actually basically allows you to write NetsBlox programs that can control these Wi-Fi enabled robots. So the code runs in the browser, and the exciting thing is that this makes it possible actually to have, say, like a class of students controlling a group of like 10 or 20 robots, where topics like cybersecurity kind of emerge naturally, and certainly seem a lot more relevant and tangible than or in this distributed and Wi-Fi enabled environment, as opposed to when, say, like the device is connected directly to your laptop. Topics like encryption are a lot less compelling when there's no opportunity for anybody to overhear or interact with your device, in other words. But anyway, this has been a summer camp that's run for a few. Sorry. That we've run for a few years, and there we go. Run for a few years, and it has been a lot of fun, and and there's been a lot of engagement and stuff with it as well, which is always exciting to see. But recently, we've actually been pushing this further, especially in light of COVID, to actually take Roboscape entirely online. In other words, rather than actually having physical robots and students in a single room, where the robots are, of course, Wi-Fi enabled, we're actually bringing this all into virtual reality. This is nice not only for remote learning, but also because there is no actual like hardware cost, because there's no maintenance for upkeep and things like that. So it should be a lot more accessible. And of course, like everything else, this is something that we've been working on in the open source space. In other words, doesn't cost any money, and the code's publicly available, and all this kind of exciting things about open source. So this also, Roboscape Online and working in a VR environment gives us a lot more flexibility to explore more complex scenarios, like the one in the top right, where you have a conveyor belt bringing blocks onto this large platform, and the robots push the blocks off the edge. And of course this one in the bottom, where we have a traffic light scenario where students are trying to write code to control the traffic lights to maximize like the throughput, but also fairness, at the intersection here. We have a quick demo here as well of the Roboscape environment, particularly the traffic light control scenario.
To determine where cars are waiting. Students are tasked with creating a controller program for the signal to improve the flow of traffic. Both the sensors and signal are exposed to NetsBlox's web services, so students have blocks available to send commands to change the light's colors. On the screen now is a simplified program which pulls the traffic sensors in one direction and changes the light based on the vehicle's present.
So one thing that's particularly exciting about developments like these are that they really open up a lot of new possibilities when you're trying to learn programming, especially in the context of robotics and cybersecurity, and a lot of these really related and relatable topics in today's world. Not only do they make programming, I think, more relevant and engaging, but they also are very complementary. So some of these, so for example, like if you look at Roboscape and Phone IoT, they don't need to be used in isolation, but in fact can be actually much more powerful when used together. For example, the students in this past summer camp actually were using Phone IoT to configure a controller for their robot. So they wrote code in NetsBlox, shown here in like the lower left, that created a created a mobile controller. This is an example one, not one that was used from the that the students created, but students made some like these, where they had a a controller configured on their mobile phone using NetsBlox, which would then send messages through to Roboscape to control a robot in the virtual reality environment running in the cloud. Alright, we have one more demo of this in action, although this one of course isn't from one of the students, but or from the summer camp anyway. So here we can see that the girl on the screen is using her phone and phone IoT to control the robot, in this case the physical robot, using the joysticks and the controller that she made within NetsBlox. So with that, I'd like to wrap up and say that I'm excited about some of these opportunities that opening up the internet makes for novice learners. Hopefully this will allow them to go through much richer and maybe more engaging curriculum that speaks to their own unique set of interests. We with NetsBlox try to make that possible by making a variety of different online data sources available and services, like through Google Maps and COVID data and text analysis concepts, as well as other climate science data sets and a variety of other web APIs that are integrated, but also of course making it more interesting through integrating with robotics and in both real life and in a virtual environment, and working with your phone and a number of other contexts that really make the number of projects that you can make seemingly endless anyway. Like we also recently added integration with Alexa, so people can create voice their own, or customize their voice assistant through custom skills and intents from within the NetsBlox environment as well. The hope again, and our goal is to really empower students to be able to create projects that interest them and are relevant to their own lives, because in doing so, this should hopefully promote engagement with technology and these computer science concepts. And the approach that we've taken in NetsBlox has been by introducing a small set of powerful abstractions that are supported just by a few or a handful of simple blocks to keep the learning curve as gentle as possible, and still, of course, make all these exciting possibilities possible. With that, I'm going to finish off by just thanking all the many people who have worked on this project and giving and sharing some of this credit, just because this project has been a very much a group effort across institutions and supported by a number of different funding institutions as well. With that, I would like to thank you for your time. I'll make these links or these slides available so you can follow these links, check out the documentation, some of the step-by-step guides for some of the applications that we did today, and these guides actually and I think both cases take it even a bit further than what we covered today. And of course, invite anyone to reach out to me if they have any questions or would like to just learn more in general, I guess. So, thank you everyone for your time, and hopefully you enjoyed it.